Hi everyone, today we're going to work on Descartes' rule of signs. The idea here is we can tell how many positive answers and how many possible negative answers we have given a large polynomial. And let's start off with our polynomial. It's going to be negative x to the fifth minus 4x to the fourth plus 2x cubed minus 2x plus 3. Okay, so the idea here is this has a bunch of zeros as answers, right? When will this equal to 0? And we can tell if those solutions are positive or negative, or the possible number of them. And the way it works is we first are looking for positive. So let's look for positive solutions. And all we do is we count the number of sign changes as we go down the list. So example is we start with a negative to a negative. Did we change signs? No, we went from a negative to a negative. But when we go to the next term, it switches to a positive. So that's going to be one sign change here. And then we go from a positive to negative. Now we're at 2 sign changes. And then from negative to positive, now we're at 3 sign changes. So we can conclude that we have at most 3 positive solutions. Descartes' rule of signs doesn't tell us what those solutions are. It's just that they are possibly 3 positive solutions. And then what other possibilities we have is we minus 2 from that. We always subtract by in sets of 2. So it could also be 3 minus 2 is 1 positive solution. Okay, so we could have 3 positive solutions. We could have 1 positive solutions. But to remind ourselves, remember this is x to the fifth. X to the fifth should have up to 5 solutions. So this answers the question, can all 5 be positive? No. At most, we can have 3 positive solutions. So now to figure out how many negative solutions we have, we actually take our problem and we're going to go ahead and plug in a negative to each of these x's here. So we're going to take it, we're going to plug in a negative. So if I take a negative, plug in negative, right? I'm going to plug in a negative to each of these. So let's walk through it. If I put a negative into x to the fifth, that would be negative, 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 negative. And that would be, the result is a negative, but there's a negative in the front. So that's going to be a positive x to the fifth. A positive x to the fifth. And then over here, to the fourth power, negative, 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 negative would be positive times a negative. That's still a negative. And then over here, x cubed, negative, negative, negative times a positive is going to be a negative 2x cubed. Plug in a negative here, a negative and a negative becomes a positive 2x. And then a positive 3 doesn't change. So now to find the negative solutions, we go ahead and plug it in. We now count our sign changes after we plugged in our negative. So we go from a positive to a negative. So that is 1 sign change because we went to positive, negative. Then a negative to negative, no sign change. A negative to a positive, that's 1 sign change. And a positive to a positive, that's no sign change. So we have at most 2 sign changes. So 2 negative solutions. And again, like in the positive case, we subtract 2 to figure out what other options we have. So 2 minus 2, that gives us 0 negative solutions. Okay, so I'm going to make a quick chart here. We could have positive or negative solutions, okay? And then we could, if we don't have positive or negative, we're going to have imaginary solution, I solution, okay? So we could start off with 3 positive solutions and 2 negative solutions, and that gave us our total of 5, right? Remember how we were supposed to get 5 total? And that means we have 0 imaginary solutions. That's one possible set. We could have 1 positive, 2 negative. Now remember, we need 5 answers total, so that means we have 2 imaginary solutions. We could have 3 positive and 0 negative, and that would still be 2 imaginary solutions. Or we could have 1 positive and 0 negative. That would lead us to 4 imaginary solutions. So that's what Descartes' rule of signs allows us to see all the possibilities. We could have, again, 3 positive and 2 negative answers, which gives us 5. We could have 1 positive, 2 negative, and 2 imaginary. That still gives us 5. We could have 3 positive, 0 negative, and 2 imaginary. That gives us 5. And we have 1 positive, 2 negative, and 4 imaginary, which gives us 5 possible complex solutions. Okay.